Well,
or both?
I was just planning to come on Wednesday, so.
Okay. Okay, so we are recording right now. So let's go ahead and we have this quotient of power. So yesterday we worked with product of powers, which means we multiplied. Now this one, it says simplify, write each answer in exponential notation form. So notation form. So remember, that's -2. Now you need parentheses. -2 cubed. Now I'm going to jump down to this one. This is 9/11 to the 4th.
Not sharing your screen.
Oh, so sorry. Thank you.
I thought you knew you weren't sharing.
Okay, can you see it now?
Yeah.
Okay, so thank you guys. First, it's been forever to see the chat was I'm sharing and focus on the lesson. It's like a student who has a hand up in class. I'm like, okay, we're working. Anyway, so -2 cubed, use your parentheses. 9/11s, use your parentheses to the 4th. When you have a fraction or a negative base, make sure you put those in parentheses. Okay, remember what's 5 squared times 5 to the 4th in exponential notation form? Good. 5 to the 6th. When you multiply by the same base, add the exponents. When you multiply by the same base, add the exponents. What about this one? It's going to be 8 to the 6, 3. Don't forget this, a 1. So 8 to the 10th. Okay? So that's the one that people forget. There's an exponent of 1 there. We just don't write it because it's automatically assumed it's 1 or 1 there. Now, what does this word mean? What does quotient mean?
Isn't it like division?
Yes, it's the answer to a division problem. So answer to division problem. If you want to write that down. You don't have to, but you can write that down if you want. So we're going to write out expanded what this means. This is saying 3 to the 6th power. Well, 3 times 3 times 3 times 3, 1, 2, 3, 4, 5 times 3 divided by 3 times 3. There's 6 of them on the top and there's 2 of them on the bottom. What do we know about anything divided by itself? What is anything divided by itself? If it's 3 divided by 3, 4 divided by 4, a million divided by a million, x divided by x. Good. It becomes 1. Anything divided by itself is 1. So what's happening here is we can actually cancel out. We can cancel out these 3s. We can cancel out those 3s. Those actually cancel out. There's 2 3s on the top and 2 3s on the bottom I could cancel. What do I have left? Good. I have 3 to the 4th left over. I have nothing in the denominator. So I don't need to put this 3 to the 4th over 1. I can just leave it 3 to the 4th. Okay, now, -2 6 times. Now, with negatives, I go ahead and just do parentheses. And that represents my multiplication. I don't put a dot or an X in between them because it's not needed. So I'm just going to do -2 to -2 6 times divided by -2 4 times. How many can I cancel out? I can cancel out 4 of them because I have 4 below that I could cancel out 4 on the top. So I have -2 to the 2nd power. Again, you must have parentheses, not this. These are 2 different answers. This is -2 times itself. This is 2 squared and then the opposite. So that would be a -4 while that would be a +4. So make sure you have parentheses. Are you guys noticing anything from here to here? Look at your exponents. See if you notice something. And if you do, feel free to jump right to here. Otherwise, you're going to have a painstaking write this all out stuff. 1, 2, 3, 4, 5, 6, 7. We have, what is that, 2. They can't, 2 of them cancel. And I'm left with 5 to the 5th. So I'd like not to have to write this out 8 times and 7 times. How many more do I have on the numerator than denominator?
One.
Good. I only have 1 of those left, so that's just going to be 5/8. So I can have 5/8 times 5/8 times 5/8, 8 times. And then the 5/8 7 times on the bottom. But I'm going to, when I cross it out, I'm going to have 1 more on top. So what's happening with the exponents to get to our answer? We have 6, 2, we get 4. 6, 4, we get 2. 7, 2, we get 5. Call it out. What's happening? When dividing by the same base, what do you do with the exponent? Anybody? Does anyone see it? 7 and 2. We get 5. Okay, if you're doing it, just did. Please set it. Oh. Lawson, sorry. Your mom yelled at you. Okay, I think even. Oh, maybe Lawson, you're telling me that she. I don't know. I just now saw chat. Good. Same base. Subtract the exponents. So in multiplication of the same base, you add the exponents. With division, you subtract. Okay? So when you multiply the same base, you add. And that's what the quotient means. If you have to, you can do a screenshot. But you're not turning in your screenshot to me. I mean, you're not turning in work. You're going to need to write it down. Okay, so now let's do some practice problems. Oh, now this one you got to be careful. Okay, well, let's look at expanded notation, exponential and then expanded form if we need to. We have a -4 to the 6th power. I don't know why I switched that. -4 to the 6th power divided by -4 to the 6th power. So if we did this 6 times, numerator, 2, 3, 4, and 6 times in the denominator, what happens? We had 6 times in the numerator and 6 times in the denominator. Cancel each other out. But the thing is, everyone thinks it's going to be 0. But whenever you divide by itself, it always equaled what number? Not 0. It equaled
1.
1. Now, what happens if we subtract these numbers? What's 6 minus 6? 0.
0.
But anything divided by itself is 1. So here's the thing. Any non-zero based raised to the 0, I'm going to go back and forth. I'm going to go from here to here. 0 power is always 1. You might have heard that before. Why? Because notice when we subtract, there's 2 properties that's happening. Quotient and powers property. When you subtract, when they're dividing, you get 0. But then when the identical thing that you're dividing by, -4 to the 6th power, -4 to the 6th power, that's the exact same thing. Anything divided by is 1. Anything risen to the 0 power equals 1. So for example, 5 to the 0 power, that's 1. B to the 0 power, that's 1. I can make it look like a crazy x, y cubed, z to the -8 or 6, all to the 0 power. And you're like, what? Well, if the 0's on the outside of parentheses, that's going to equal 1. Now, we're not going to get into variables this year. Next year you will. So don't freak out about that. But if it looks like a crazy problem, it's all risen to 0 no matter what. Okay? So it's 0 power. So stop unmute. You're going to say anything risen to the 0 power equals 1. Go.
Anything Wait, I forgot the rest.
Anything raised, any non-zero base, but that's okay. Non-zero base raised to the 0 power is always 1. Something like that.
Any non-zero base raised to the 0 power is always 1.
Nice. And I only heard Charlotte.
Said it.
And Charlotte's the one who said it, and I guarantee she's going to get that right every time, and the rest of you might make a mistake. Or you can... Thank you, Charlotte. Okay, now, watch this. Look at these numbers. 5 to the 3rd power and 5 to the 5th power. Well, look what happens. We have only 3 5s on the top, but 5 5s on the bottom in the denominator. So which one has more 5s, the numerator or denominator?
Denominator.
Denominator. By how many?
2.
2. So this one is actually saying, now, since you crossed everything on the top, you have to have a 1. You have to have a 1 in the numerator. Don't leave that out. You can leave the denominator out of 1, but you need the numerator. So exponential notation. So really what happens here, it's 1 over, you have 2 more 5s in the denominator than in the numerator. Now I will tell you, when you have a fraction like this, we do want to go ahead and expand out 5 squared. It's just typical to go ahead and expand it out. So what does 5 squared equal? Good. 25, not 10. Be careful. It's 125th. Okay, now let's look here. -2 is our base.
Wait, I have a question.
Oh, sure.
You probably already said this, but how come we didn't put parentheses around the 5s?
Oh, good point. Oh, I don't know. And actually, the 5 didn't really even need parentheses to start with. I don't even know why I didn't put them here, but I did. So, but okay, good point. Yes, good idea, and keep it. Yeah, I guess it really didn't even need it at the beginning, but I'm glad you asked because that makes sense if it starts with the parentheses. So, yeah, I don't even know why I put that. You really don't need it, but that's okay. So -2. I'm glad you asked that. How many more -2s do we have and where do we have them? Which one has more -2s? Numerator or denominator?
Denominator.
Denominator. By how many?
3.
Good. So that's going to cancel out. You're going to have 1. Now keep your -2 in parentheses. This one, since it's a fraction, we typically will write the -3. And I got to show you something else that this is doing. So this is going to be 1. Now, -2 times itself 3 times is going to be a -8. So -2 times -2 times -2 is a -8. Now, let me ask you this. What is 3 minus 5? -2. So this is saying 5 to the -2nd power. So what's happening, it's moving when you have a -2nd. So I'm going to probably have to continue this, I know on another taping, but 5 to the -2nd. So what it does, it actually brings it down to the denominator. When you have a negative exponent, it actually flips it and brings it down to the denominator. So we're going to do some practice down here. To the -3rd power, where it gets confusing. When you have a negative exponent. So I'm going to stop and let me stop.